Sorry? To from? The way it works, and that's how we're going to solve this exercise, is think of it as two separate questions, which will be number one, do we need to send the data, the value, the original value, to the GPU? That's 2. Do we need to get the final value from the GPU? Yes, no, that's the from. If you have one or the other, that's 2, or from. If you need both, that's the 2 from. So that's exactly the question I'm going to ask for every single variable, so you can get this little voice in your head about how to approach this data mapping, which we can start right now, actually. So, first step was, before we think about data mappings and everything, is to actually transfer the execution to the GPU. How do we do that? Yes. Let's make sure we're transferring the right section. Okay. Now, if I try to execute this, it will execute successfully. The results I'm going to get will not be the ones that I expect. And maybe some of you try to submit at some point and find a print statement that was not making sense. Yes, so it means somehow something was a bit maybe incorrect. So let's do them one at a time. Variable b. Who says it's a 2? Okay. Who says it's a 2 from? Okay. Who says it's from? Okay. It's interesting because we have a bit of the class in every choice. So, do we need to send the original value? No, in this case. Why? Because the first thing we do is we overwrite the value with 20. So no matter what value b had, it's going to be overwritten anyway. So we can save the actual transfer. So the 2 won't be here. If the 2 is not here, it means it cannot be 2, and it cannot be 2 from, because 2 from is nothing else than 2 plus from together. So if we don't have the 2, not 2 from. Then only have the from left. Why? Because we need the value back. Why? Because we want to print the new b value in the print statement. But we don't have it on the host yet. We have it just on the GPU so far. So we have a map from for b. Okay. Result. Who says 2? Who says from? Okay. Who says 2 from? From, okay, and 2 from? Just to be sure, no? If there's no 2, there's no 2 from. If there's no from, there's no 2 from. Works either way. So map, we said, we said from, so we can just change it here. Okay. A. Who says 2? Who says from? 2 from? Okay. Yes, it's 2. We need the value at the start. We don't need it at the end. So x 2. Okay. From? 2 from? It's 2 indeed. Same. All these types of read-only variables are 2 by definition. We'll need the value at the start, but we'll never return it. Why? Because it's the same value at the end. Yes. Which one, sorry? Why can't we? We can. Is it going to make the program incorrect? No, it's not. It's just that if we take b, for example, it starts with value 10. So I'm sending 10 to the GPU. The first thing I do is I turn this 10 into a 20. And then I bring the 20 back. So me sending 10 at first does not interfere with correctness. It just makes me pay an additional data transfer that I don't really need to pay. So it's just performance optimizations here. if we try to save and compile, is it happy? I made a typo somewhere. It seems to be happy. Let's submit. Watch. I hope I have the right. I didn't put a typo in the name. Here, none. Is there anyone maybe already running? Maybe that's the case. Ah, okay, cool. 1 times 10 plus 20 equals 30. Good. Yes. Unfortunately, no. Not as far as I know. That was my first thing, because if there had been a default none, trust me, by now, I would have said, use default none. No, unfortunately, for GPUs, yet we don't have this default none. If I'm saying something correct, or if I missed an OpenMP update somewhere, and you know about it, please tell me, right? Don't let me say something you know now is wrong or has become obsolete. So, in case. Okay, so now we're going to focus on something else called data environments. Because so far, we can transfer the execution to the GPU, great. We can transfer the data we need to the GPU, even better. And we have a lot of bandwidth, but between the CPU and the GPU, we don't have the same bandwidth, okay? So why would we want to have something else than what we've just seen? We have mappings, so we're good to go, and now there's nothing else to do about it. Well, actually, there's a new construct called target data, which is going to create what's called a data environment, which means the data is going to, the transfer that you want to happen is going to happen over a period of time that may exceed that of a target. Let's take an example. You want to send a target, you execute a target, so you send some data and you bring some data back. You're not updating these data, but you launch another target afterward and you send this data again and you bring it back. Effectively, this back and forth systematic means that you're returning some data from the GPU that you don't want. You wish it was just staying there, because when you're going to finish a target, that data on the GPU is gone. So next time you call the target, you need to send it again. The data environment is going to tell the GPU, okay, I'm going to send you some data, hang on it, because I'm going to use some targets afterwards, so keep that data on and don't delete it just yet. Wait until I tell you at the very end of the curly bracket to free everything. Yes, so that's okay. Now, please do not make this mistake. I have raised this point in the OpenMP language committee. Target data is a construct. It's not a target construct with a data clause. In other words, target data, there's the word target in it, yes, but it does not transfer the execution to the GPU, okay? See target data as a single word, totally different. Call it TD if you want, so that you don't even see the word target in your head. Call it TD. It's a different construct, like parallel and critical are totally different constructs, okay? If you want to transfer execution to the GPU, the only way to do it is just with a target construct that you have at line 6, at line 11. That transfers the execution. Target data does not. Good? Okay. So what happens here is we're going to send the variable A at line 3, and it's going to stay on the GPU until line 16. And we'll bring it back only then, okay? You may say, yeah, but why do we still have the map clauses for like line 6, line 11? It's because at line 6, you're going to say, okay, for my target here, I need the data to go on the GPU and to come back. But your data environment, when the runtime from OpenMP is going to say, okay, we would like to send this data to the GPU, it's going to check am I part of a data environment? Oh, yes, cool. Okay, this data environment, did it say that the variable was already sent to the GPU? Yes. Oh, so the data is already on the GPU, so I don't need to send it then. Oh, cool, thank you. And just move on, okay? So it allows you to still making sure that you're doing the right mappings for each target, while also creating data environments to remove some data transfer you no longer need, without having to change your individual targets. Okay, so it allows you to incrementally improve your program, which is one of the big strengths of OpenMP compared to MPI, for example. And I'm an absolute fan of MPI, but it's just that MPI, if you want to move to MPI, you have to rewrite your entire program directly. With OpenMP, you can just drop a little pragma here, a little pragma there, so it's really step by step. So you can really change your code one step at a time. So for Fortran programmers, same thing. Yes? Yes, you're right. We don't need to actually send the value there. We can just tell, oh, you have a variable, don't bother about the value. Yeah, you're absolutely right. The 2 was not needed here. Same thing here. This is very useful, data environments, where when you have the global view. So you know exactly, oh, at line 6, that's where I send it, at line 25, it's when I receive it. Great. But sometimes it doesn't work this way. Sometimes you need a bit more of an arbitrary approach. If you're in C++, for example, or if you want to have a function that will allocate some data on the GPU at some point somewhere in your code, and it's a totally different function that may be called at some point somewhere in your code that will free that data. Okay, it's no longer needed on the GPU, so you can free it. This you cannot encapsulate in a single nice curly bracket section. Okay, you may not have the view on this when you start to call. So you need to have this ability to decouple the start and the end. To do it, we just see 2 new constructs. Again, constructs. So target, enter data, target, exit data. None of this transfers the execution to the GPU. This is just for the data movements, okay? Very confusing, I know, but it's target, enter data. See it as a new construct called TDE, or enter D or something, okay? So that it doesn't clash with exit. Now here we're going to see 2 new map types we haven't seen yet. We've seen to from, and now there's alloc and delete. Alloc and delete are asking the GPU to allocate some value, so far so good, without triggering any data transfer. And it can also allow the GPU to delete some data without resulting in a data transfer. To from, you have at least one data transfer happening somewhere. With alloc and delete, you can do everything without never doing a data transfer. So it's even better. You can control the GPU and you can create temporary variables or anything there directly from the host. So that's what you use alloc for. And it's fairly easy to use, again, just like with a map, really. If you want to allocate a variable A, you do it this way. There's no transfer either in one way or in another way here. Okay, there's no map to from here. And the delete is the opposite. Oh, yes, sorry. No, it's the same thing. It's, how do you mean 2 names? It's a single name. That single name points to different pieces of data because the host and the device, the host and the target, do not share memory. Again, I'm excluding USM here, a unified shared memory, which is actually what now GPUs can do and so on. So it means that that's why we transfer variables to begin with. We transfer the data. It's because the GPUs cannot access the CPU's memory directly, and the CPU cannot access the GPU's memory directly. So they need to have these data transfers of, oh, you need that data? Cool, I'm going to send it to you. Okay? Yes. Okay, yes. The variable you want to allocate on the GPU must match a variable that exists on the CPU. Okay? Yes, that's a good one. Any other question? Yes. Yes? So now you have a variable on the GPU that you don't have on the CPU. Well, it depends. In this case, I'm taking an example where I would need this variable A well, I would have a variable A also on the CPU, but it happens that I don't need any data transfer for the GPU. Maybe because I would like a GPU version of this variable, but disconnected for some reason. Okay. Yes. A bit louder, please. Sorry. I would think that now, yes, since I explicitly mapped it as an alloc, it will, by default, it would become, that's a scale, so it would become the weird first private. I would think that now, this malloc, this map alloc is going to prevent us from having this automatic transfer. But that's a good one. I'm going to have to check this one now. Because the way it works behind the scenes is there's what's called a conflict resolution process, which is when you map your variable with target data as map, as a to or to from, and when you have a given target, you say, oh, for this target, I need a to, please. You have a to here, you have a to from here, so I need to check if that resolves to, oh, the data is already there, don't worry, or, oh, no, I need now to transfer it. That's called the conflict resolution. Okay, or data mapping resolution. So the map, oops, sorry for that. Yeah, the map is to free the data on the GPU without resulting in the data transfer. Again, GPUs, computational tanks, but weak for data transfer. So as soon as you want to optimize a GPU program, you're going to focus on data right away. Okay. Now you may say, okay, nice, we have the alloc, we have the delete, but what if at some point I want to have an idea of what the value on the GPU currently is? Like at this second, I would like to print it, but I don't have it. How do I bring it back? I don't have a target to execute, I just want to bring the value back or send an updated value. Another construct called update. So this one is fairly simple. It's going to punctually allow you to either have a peek at a variable's data right on the GPU by effectively bringing it back, so that transfers data, or doing the other way around. You're going to send data from the host to the target, okay? To use it, this is how you can do it. Here we have a target that sets the value to 1, 2, 3, and I would like to print that value on the host. The host doesn't know about this value yet. Why? Because it's not brought back directly at line 4. It will be brought back at line 13, at the end of that data environment we have created. Okay? The whole point of the data environment is to prevent these automatic transfers. So if you want to bring it back at that specific point in time, target update from A. And now it will take that data from the GPU. So you have on the host the updated value. Make sense? Can I clarify what, sorry? So the data map is going to say, I'm going to put some data on the GPU or take it from the GPU at some point, so prevent all these automatic maps that you will see in the targets unless they conflict. So the typical case is, I'm going to put some data on the GPU, and so it will be there already. So every time I'm trying to send data to the GPU, ignore, because it will be there. It's even if you say map to in your data environment, and then you say target map to, target map to, target map to, they will be ignored because data is already there. Same for from. Which is why we need now these punctual updates. Because it's still good. If you don't put target map, it means you put target and the default mapping. The default mapping may not be the one you want. Yes, you explicitly say what you want. Because if it's an array, remember, arrays by default are to from. If you wanted to pass the array as a from in this first target map, and you don't put target map, it means by default, implicitly, you just wrote something like target map to from. Your data environment says only the from are already covered. So if you do a to from, it will say, okay, you're asking for a to from, your data environment just says from. Oh, so I'm going to have to do the to now. So I'm going to have to actually trigger that data transfer. So that's why you always need to say exactly what you want. Again, this is not for correctness in most cases. It's typically for optimization. Note something here that I found a bit tricky at first. Yes. 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 Now the value of A at line 9 on the CPU, on the host, is 1, 2, 3. Now it's initialized. Note that when we use target map from, the from is a value inside a clause. Okay, it's the map type inside a clause, but the clause is map. When you use the target update, from has now become the clause itself. So it's from and then parenthesis something. Okay, that's a subtle difference, but it's a mistake I definitely made a few times. So if I can spare you that mistake. So that's how to fetch data from the GPU, but you may want to do the opposite. So if you have this case here where on the host you update the value and you want the GPU to rely on that new value, you do it the other way around. You do your target with a 2. And now you're effectively told the GPU, oh, by the way, before you go any further, that's the new value of A. Okay, now you. Okay? Well, then if it makes sense, time for you to have fun, and then we'll have the break, and after the break, we're going to have fun with something else. Yes? Just on the GPU. Just on the GPU. Which is going to impact something else afterwards. You'll need to free on the GPU before the CPU. Because the CPU and the GPU need to have that kind of mapping, if you want, that existence of variables across both. They need to know where it maps. Yes? Line 2, yes? Yes. No, remember, that's a very tricky part. Target data contains the word target, so it sounds like it's transferring the execution to the GPU, but it does not. Target data is not the target construct, because it really looks like it's the target construct with a clause called data. But no, it's really a totally different clause. As far as you're concerned, you can really see this target data as something called Pragma OMP TD. So it's not Pragma OMP target. It does not transfer the execution to the GPU. Exactly. You're still on the host until line 4. Only the part that have Pragma OMP target map will execute on the GPU. Target data, target enter data, target exit data, these are not target constructs. Again, I'm really trying to get that changed in the standard because it's still fairly young, so I think we can rename the entire construct. because that's confusing. This space in the name is very confusing because it makes it look like there's a construct and a clause next to each other, but it's not the case. Yes? If you didn't have the data environment, it would be fine because the data would be moved every time. Well, moved from every time. Since you have the data environment that says, oh, I'll just bring it at the very end, when you try to do it, it says, oh, you already want to get it at the end, so I'll wait until the end. Yes, sorry. Exactly, and that's the whole value of the data environments, is that it makes you save the data transfers. The idea is to say, rather than bringing it back every time or something, you're like, if only I could leave it there, like, so I can do my 3 different GPU kernels or GPU shaders or something, without having to bring the data every time, because that penalizes me. These 2 gigabytes, let's say you're processing an array of, massive array, of 200 gigabytes. Let's assume you have infinite memory on the GPU, infinite memory on the CPU, right? And you have to transfer these 200 gigabytes. That's 100 seconds just for the transfer, before you even start to process it there. We exclude streaming technique and everything. If you can just transfer it once, and then do all your kernels and work on it for hours and hours, yeah, then you're happy. And you just transfer it back once if needed at the very end, and that's it. Yes? Oh, by the way, it's the coffee break now, 10:30, I believe. So feel free to go for the coffee break while I answer some questions. If you have more questions, I'll be here. Otherwise, enjoy the break.